Hello, welcome to the video notes for lesson 10-1. This lesson is the introduction to similarity, the new topic that you have in math. Let's start with the learning targets. There's two of them. The first one is I can use scale factor. Hopefully that's a word you remember from your past. Use scale factor and proportions. There should be another familiar word to determine if figures are similar. Now you've probably heard that word similar. We're going to talk about that more in terms of math in just a few moments. The other learning target is I can use scale factor, there's that word again, or that term, and proportions to determine the missing sides of similar figures. Alright, so let's talk about what this word similar or similarity means. Figures are said to be similar if their corresponding sides are proportional and the angles are equal. Now that corresponding sides is a very key element to this. Basically, that's the sides that line up. Like the top lines up with the top, the bottom. You get it. And that's very important. So they are proportional. That means, it doesn't mean that they're the same. It just means there's a relationship there. But then the angles are equal. And that's kind of a tricky thing to tell because unless you have a protractor or some way of measuring, you'll need to understand that they are the same if they're similar. Alright, so let's go ahead and move down to the bottom of the page and examine our example a little more closely. So it says, which figures are similar to Mr. Wump? This odd looking character here is who we are calling Mr. Wump, Mr. W. One that does not work is this one here. This figure is stretched, and by stretching it, not only are we changing the length of some of the sides, but that also impacts the angles. So when you stretch it, the angles are no longer the same. So this one doesn't work. This figure here, if you look close enough, if we were to pick this up and drop it on the original Mr. Wump, this one would be congruent. And that's not what we're looking for. We're looking for similar. We want it to basically be the same shape, same angles, but the side lengths are different. The other two are similar to the original. This one here is smaller, and this one is obviously larger. Now if we were talking about the corresponding sides, so you got this top part here, and I know I'm doing a terrible job with my lines because I'm not using my line tool, but there's a relationship between the top of these three figures and any of the other straight sides that you find. Let's say the original, the top is 5 centimeters. This top might be 2.5, which is 1/2 of the original. And this one might be 10, which is double the original. So there's a scale factor there. In other words, we can multiply any one of them by a number to get any of the other ones. So that's the relationship with similar figures. They're the same shape, but a different size. So that's kind of the basic way to put it. Alright, so let's examine this a little better on the next page. And this is a good time to talk about a new symbol. So here it says prove triangle ABC and then triangle FGH, and there's a funny looking symbol in between. So you've learned about the symbol for congruent. I want you to put a star at the top. This is the symbol for similar. And it looks like the little squiggly or mustache that you would put in the congruent symbol. So we're going to talk about the sides being proportions. or proportional. Alright? So this side AB, if I look at side AB, and by the way, the correct way to write this is like this, and this little symbol above the AB is a line segment, so, or side AB. That side goes with side FG. And let me do that. I need my little segment symbol, FG. So if I were to put these into a fraction or a proportion, when I plug the numbers in, what I'm going to get is something that's going to equal to all the other corresponding sides. So AC and FH go together, and then obviously you can tell the last two. So the last two would be BC and GH. And all these proportions are going to be equal. How do we know? Well, if we go ahead and substitute, because these are similar figures, well, actually we're proving that they're similar, and we're going to prove it by showing that all the sides are proportional. So I'm going to take this 8 for AB and 12, and I'm saying that this fraction, or this proportion, where we're about to create a proportion, is equal to 10 over 15, which is also equal to 12 over 18. And the best way to do that is to simplify all these. Obviously, if you're using a calculator, you can get the decimal equivalent. But if I simplify these fractions, I get they are all 2/3, which conveniently is very similar to our scale factor. Alright, so there is a magic number that I can multiply any of these sides by to get the corresponding side. So for instance, if I take this this side 12 here, the FG, what would I multiply that by to get 8? Well, I have my scale factor of 2/3. And if I multiply that by 2/3, I get 8. Same thing with 18. If I multiply 18 by 2/3, I will get 12, and then 15 times 2/3 gives me 10. Now some of you might be saying, well, what about if I go the other way? Actually, what's nice about that is if I take the reciprocal of this scale factor, it will work the other way. So what would I multiply 10 by to get 15? You would multiply 10 by 3 halves, or 3 over 2, and that will give you 15. So scale factor, finding that scale factor is an important part to understanding similarity. Alright, so we have another example below this that we're going to talk about. Prove rectangle BIRD, bird, and rectangle worm are similar. So remember what similar means. Same shape, different size. These are both rectangles, so we know the angles are all the same. All we need to identify then is, are the sides proportional? So is this side here proportional to this side? Or if we create a proportion, I should say, if BI over WO is the same as IR over OR. And so let me write that down. BI, side BI, over WO, whoa, is that equal to IR, side IR, over OR. And all you have to do is plug in your numbers. So 9 over 6, is that equal to 15 over 10? And the answer is yes, because if you simplify them, you get, this is 3 over 2, or 1 1/2, and that's the same as 3 over 2, or 1 1/2. You can also find the scale factor, which is this number. So same thing, what would I multiply 15 by to get 10? You would actually multiply that by the reciprocal, 2/3, or what would I multiply 10 by to get 15? 10 times 3/2 gives me 15, or 15 times 2/3 equals 10. So there's a scale factor. There's something I can multiply all of these sides by to get all of these sides, or the other way around. Alright, one more set of examples to look at over on page 3. I know the video is getting kind of long now. The ratio of their corresponding sides of similar figures is called the scale factor. So one of the most famous right triangles is a 3, 4, 5 right triangle. You're going to learn more about this at the end of the year when we learn about the Pythagorean theorem. Using scale factors, we can create similar 3, 4, 5 right triangles. In other words, we can create bigger or smaller right triangles that basically have the same angles, and the side lengths are proportional, but they'll be different sizes. So they're giving us some different scale factors to use. So for instance, here's 2. So I'm going to multiply all 3 of these sides by 2. So 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10. So another example of the 3, 4, 5 triangle would be 6, 8, 10. I could multiply all 3 sides by 7. Actually, I'll let you do that on your own. I'll help you with the last one. You're going to do 7 and 1.5. So I can multiply 2 by 1/3, and when I do, I get 2/3. I can multiply, or I'm sorry, not 2 by 1/3. Whoops. The first side is, let me start over. First side is 3. So I'm going to multiply 3 by 1/3. And that gives me 1. And then I'm going to multiply 4 by 1/3. And if you do, that's not a nice decimal, so let's leave it as a fraction, 4/3. And then the last one, 1/3 times 5, and that's 5/3. This is going to be the same triangle that you have here, only much smaller. So it'll look like maybe like this. Same angles, but the side lengths are different. Alright, that's it for this lesson. If you had any trouble, go back and watch it. Your job is to finish the other 2 scale factors for this. Good luck, and we'll see you in math.